Hello, this is a video to go over what we did today for continuing our work with functions. Today was day 6, so here we go. Firstly, a quick announcement that we have a math quiz on Monday the 28th, and this will be on function tables, graphing, linear functions, arithmetic sequences, and geometric sequences. We have already done function tables and graphing, and then today we are looking at linear functions. Tomorrow we will work on arithmetic sequences, although we did take a brief look at it a couple of weeks ago, as well as geometric sequences will happen in the next couple of days. Additionally, the quiz will include things like mapping diagrams. So if you remember, we were doing mapping an input to an output and making function tables. That's already part of this. All right, so today we looked at linear functions. Before we get into that, we did a quick little warm-up. What is the output if the input is -1, given this particular set of input and output values? Well, we can see that there is definite relationship between the input and output, and the relationship is that I am adding 7 each time. So if I add 7 each time, I get the output. Therefore, if the input was -1, which would kind of fit in right in here, and I add 7 to that, I would end up with 6. So the rule is n plus 7, and the output when the input is -1 is that it would be 6. Moving on, we are going to look at linear functions. So here's the word linear. I'll write it again right here. Linear functions. Now, if you'll notice, the word linear has embedded in it the small word line, and that's literally what linear functions are. These are functions whose graph is a straight line. So we can visually identify linear functions. For instance, looking right here at example 1b, I can see, oh yeah, this makes a straight line. Yes, it's a linear function. However, example 1a is not a linear function because it's not a straight line. These are two sections of straight lines connected together at a common vertex down here, but this is not a linear function. The graph that made this, the equation of the line that made this image happen is not a linear function. We looked at a few more examples and a few more types of situations. One, if we have an input-output table presented to us, we might be asked to figure out, you know what, these are ordered pairs. Do these make a linear function? And a quick way to do that, or one way to do that, is to go ahead and do a quick sketch of this input-output table. We can do that very roughly in our notebooks. We can also use grid paper, so it's totally personal choice. But here is a quick little sketch on just like in your notebook. And I'll go ahead and throw in some points and look at x values. I'm seeing that I need to go from 0 to 9, and for my y values, I need to go from 0 to 3. So I'm going to go up in 2s on my x-axis to try and fit it all in. So it's okay to adjust the scale. And for my y values, I'm going to go up in 1s, and my y and x scale don't have to match. It's totally fine if they don't. And I'm going to go ahead and now plot my points. I have the point 0, 0. That's right there. I have the point 1, 1, which would be right here. When x is 4, y is 2, is a point right here. When x is 9, which is right here, y is 3, that brings me right there. And if I connect these dots, I notice that I'm actually getting a curved line. So this is not a linear function because I'm getting a curved line out of it. Continuing on. Here is another example. We need to identify whether or not the diagram of x to the number of dots that are in each diagram is that a linear function? So first here, this the part above the black line that I'm just drawing is basically what a question would have, and you would need to go ahead and create the input-output table. So I'm going to go ahead and make that input-output table off on the side right here. My input is diagram number. So diagram number is my input, and my output is dots or number of dots in diagram. All right, and so I can see for diagram 1, I had 1 dot. For diagram 2, I have 3 dots. For diagram 3, I have 6 dots. And for diagram 4, I have 10 dots. So now I have my input-output table made, which I can then treat as ordered pairs and go ahead and plot those to see if I end up with a linear function. And we can see that this one indeed does not a linear function because it again is making a curved line. Continuing on, we can use linear functions to kind of compare one function against another. And here's an example of that. Let's say somebody's sister earns $10 per hour. So for every hour they work, they make $10. And somebody's brother earns $7 per hour. So we can go ahead and create our own input-output table. This one is for the sister. And here's what we have. We have hours worked and the number of dollars. So if the sister works 1 hour, the sister would get $10. 2 hours is $20. 3 hours is $30. And then for the brother, the brother's hourly rate is different. For 1 hour, the brother gets $7. Therefore, two hours would be $14, and 3 hours would be $21. We can plot each of these tables against on the same grid, which is what this image here has done. It's plotted the blue line for the sister and then the red line, the green line for the brother. So for the sister, for 1 hour, I have $10. For 2 hours, there's $20. For 3 hours, there's $30. And you can see for 4 hours, it would have been $40, and so on and so forth. If I connect these dots, I end up with the line for the sister. And then for the brother, it's a little bit different. The brother only earned $7 for 1 hour, $14 for 2 hours, just a little over $20 at $21 for 3 hours, so on and so forth. If I connect these dots, I end up with this line. And I can see that the line for the sister is steeper than the line for the brother. And what that means is that the sister earns money at a faster rate. So that's why the line is steeper. And one way to keep in mind, if you're trying to figure out which line is, what does steepness really mean? If you imagine these lines being hills you're climbing, well, the blue line would be a much steeper hill to walk up than the green line. You would be less out of breath. So that's one way to keep that in mind. We did a few just on our own, just as a class together. This right here is identifying whether or not these are linear functions. And this one, yes, of course, we can see it's a straight line. This one is a very clear no. It makes a curved line. For these tables, we would need to do a quick sketch to see whether or not they're linear functions. And then you can try that on your own to figure out if number 3 and number 4 are linear functions. Continuing on. We didn't really go over this in class very much. We did question 5 briefly, and the only thing we really did was practice how to make an input-output table with these dots that are presented. So here is input, and here is output. Remember, the output in this case is dots, so it's the the number of dots, which is y, and the input x is the diagram number. In this case, diagram 1 has 1 dot, Diagram 2 has 3 dots. Diagram 3 has 5 dots. And diagram 4 has 7 dots. And then we would go ahead and plot these points as ordered pairs and see whether or not it makes a straight line to determine if it's a linear function or not. We ignored question 6 in class. We didn't really look at it even. The next task for students was to go to page 174 in the textbook, and I've sent a copy of the textbook home with you, to go to page 174 and do numbers 1 through 14 all as practice, as well as do numbers 15 through 21 odd problems only. The homework is 4.5, and that is from the packet that I sent along with the textbook today. So that is the homework for tonight. The other thing that I wanted to talk about that we talked about in class was the study guide. So the study guide is actually included in the photocopied packet that you have. If you go towards the end of the photocopied packet, you'll notice that there is a page that says 4.4 to 4.7 or something like that quiz. That serves as a study guide, as well as the pages right after that. These are review pages. And what these review pages end up doing is that they are basically a summary lesson of each of the sections, as well as an example. So for each section that we've covered so far, as well as an example, and then a couple of or a few practice problems. So in order to prepare for the next assessment that we have on Monday, I recommend doing about half the practice problems. So you don't need to do every single one, but I recommend doing about half the practice problems from each section. And that should give you enough practice to be ready for Monday's assessment. Of course, if you need more time to be able to take the assessment on Monday, I'll be able to work with you to make that happen. But right now, while we're doing this work currently, it's a good idea to try and keep up with it if you're well and able to do the work. On Thursday, I will post the answers to the study guide things on Schoology. So answers on Thursday on Schoology, so you can check them as you get ready for the assessment. I'm not really assigning the study guide pages as assigned homework for completion to be turned in or anything like that. It is really an independent tool for you to use as you deem necessary and useful to prepare for the assessment. This was just another page, the second page of the exercises that we have. Please ignore the must do, can do. I had put that in, but then I decided that it doesn't really work because it kind of confuses people on the can do part, meaning like, it's optional, but it's not really optional. I really do need you to have that practice. You just don't have to do every single problem. You can just do the odd ones here and then do all the problems on the previous page. Hopefully that helps, and I hope to make more such videos and get those across to you. It may be that it's the end of the day or in the evening at home that I make them and then send them on to you, as opposed to as we're doing the lesson in class. But regardless, you will hopefully be up to speed with what we're doing. Don't hesitate to reach out if you have any questions. I can also set up a chance to Zoom meet with you to go over any questions you might have. Feel better, take care, stay hydrated, and I hope your spirits are lovely.